Hello, my name is Mr. Asprey and this is the 2026 practice paper that I've put together for EDEXCEL A-Level Maths. Now you may have seen my pure topics analysis video where I looked at all of the data from previous papers and I selected what I consider to be the most highest value topics, and I've compiled a question on each of those topics and I've found some really challenging ones. So this is going to be an absolute beast paper. I've actually just done it today and it was tough. But I really hope that it's going to really test you. Now, massive disclaimer, of course, none of these topics are guaranteed to be on paper one. Absolutely not. In fact, who knows, they can literally be any topic. Of course it can be. So make sure your revision is completely thorough. Number two, if you do like watching me go through tricky exam questions on high value topics, then I would recommend signing up to my live revision session, which is going to be on Sunday the 24th of May. Anyway, I'll talk more about that at the end of the video if you're interested, or you can just click the link in the description, read all the reviews. Okay, make sure that you do the paper first yourself and then come back to this video. So I want you to try the questions yourself and then you can use this video as a guide to see whether you got them right and if you pick up any tips and tricks along the way as well. Anyway, I really hope you enjoy it and let's get into the maths. Question 1, circles, part A. Part I. Write down in terms of k the coordinates of the centre of the circle. Well, it's already in the form x minus a squared plus y minus b squared is equal to r squared. So we can just read off the centre from the brackets. So the a is the centre x coordinate, and that is k. And the b is the centre's y coordinate, which is 2k. And then for the next part, it asks for the radius. Just put that here, and the radius is the square root of the right hand side, which is k plus 7. Okay, perfect. Right, on to part B, I. It says, given that this point lies on the circle, show that this equation is true. Well, if it lies on the circle, it means that we can substitute it into the circle equation. So that's what I'm going to do. I'm just going to replace the x with a 2 and the y with a 3. So we have 2 minus k squared plus 3 minus 2k squared, and that's equal to k plus 7. Okay, so we're just going to expand this out now, and it should give us the equation that we're after. So expanding this bracket out is going to give us 4 minus 2 times k times 2, so 4k, and then minus k squared is k squared. And then expanding this bracket, we'll get 9 minus 2 times 3 times 2 is 12k, and then plus 4k squared, and that's equal to k plus 7. We can collect up the k squareds, of which there are 5. The k's, we've got minus minus 16 on that side, and then we've got over here 4 plus 9 is 13, and that equals k plus 7, and then bring it all to one side, so we're going to subtract k to get minus 17k, we're going to subtract 7 to get plus 6 equals 0, and that should be what we are after. Let's just go double check that that's correct. Yeah, perfect. Okay, great. And this says, hence find the possible values of k. Okay, well, it doesn't say that we can't use calculator technology, and it doesn't ask for algebra, so we're just going to use the calculator to do this. Equation, polynomial, and we've got 5 minus 17, 6. Okay, so we get x equals 3, and not x, sorry, k. So we get k equals 3, and k equals 2/5. Okay, great. So that's that bit done. Right, now let's go on to part C. Okay, and it says that the tangent to the circle at P intersects the x-axis at the point T. Given that k is less than 2, which means that k must be 2/5, not 3, calculate the exact area of the triangle OPT. So this looks quite tricky, it's 5 marks. Let's draw a picky if it's tricky. If in doubt, sketch it out. So what do we know? We now know where the centre is, and because we know that k is 2/5, we know the centre. Okay, so let's just draw a quick sketch down here, and we know the centre is going to be it's going to be 0.4 for x and then twice that, so 0.8 for y. So it's just going to be in the positive quadrant. Again, it's just a sketch. We know the radius is going to be the square root of 7.4, or however big that is, it doesn't really matter. Let's just draw it like this. Okay, so let's just say that's the circle, and then we know that P is the point 2, 3, which is going to be like somewhere over here, I guess. So let's call that P, and then there's going to be a tangent coming down like that, and that's going to hit the x-axis at the point T. So that's going to be the point T there. So the triangle we want is going to be there, there, like so. Okay, and then across the bottom here. Okay, so what we know straight away is the height of the triangle is the y coordinate of P. So the height is equal to 3. And now we just need to work out the base. So we're going to start by working out, if that's the centre, we're going to work out the gradient of CP. Okay, so we're going to say the gradient of CP is equal to, well, the centre, C, we know was k, 2k. So k is 2/5, so 2k will be 4/5. And the point P we know is 2, 3. So the gradient will be the change in the y, so let's do 3, minus 4/5, over the change in the x, which will be 2 minus 2/5. Okay, so we do that on our calculator. Okay, there we go. So just type that in, and we got 11/8. So that means that the gradient of PT will be the negative reciprocal of that, because it is a tangent to the circle, and the radius of the tangent meets 90 degrees. So we know that gradient. Okay, and we also know a point on that line PT, so we can now say the line PT, and we're going to use y minus y1 equals mx minus x1. Sorry for all those y equals mx plus c OGs out there, but we're going to use this one, and is the much more efficient way of working out an equation of a straight line, and I'll show you why. So a point on the line is the point P, so we use that as x1, y1. So there's the y value. We know the gradient is equal to this, and the x coordinate is 2. So that's it, that's the equation of line, done. I don't need to rearrange it, I don't need to find C, that's it, done. And I can actually use it straight away. So if I want to find the point T, which is on the line, I know at the point T, the y equals 0. So I can just sub that straight into this equation here and just get going. So it'll be just minus 3 then, because the y is 0. That's the gradient, and then x minus 2. And then I can solve for x, and that just gives me the x coordinate at t straight away. Okay, so how am I going to solve that? I'm going to do minus 3, that's the right hand side. I'm going to times that up by 11 to get minus 33. In fact, I'll just show one line of working in me doing that. So we do minus 33 by timesing through by 11, and then timesing the minus 8 into that bracket gives us minus 8x plus 16. Okay, and now I think I'm good just to solve for x here. So it'll be minus 33, and then we'll minus the 16, and then we'll divide that by minus 8. Great, so we get x is equal to 49 over 8. Okay, so now we're good to work out the area of OPT, and that will be a half times base times height, which will be a half times by the base will be the x coordinate, and the height will be the y coordinate of p. So we're going to times that by, well, 3.5, which is times the same as times it by 1.5. So that's 147 over 16. So that's our final answer. And I'll just quickly show you the diagram again, just to prove why we did 49 over 8 times 3 and then halved it, because the x coordinate here was 49 over 8. So the gap along the base is from 0 to 49 over 8, which is 49 over 8, and then we times it by the perpendicular height, which is 3. Okay, question number 2, vectors. We've got the position vectors of A, B. Now I know most people prefer, or most students prefer using columns as opposed to i's and j's. So I'm actually going to write them out as columns. So OA, the position vector of A, is 3, 2, 0. And OB, the position vector of B, is 4, 2, minus 5. Okay, now it's asking us to work out the length of AB. So that is, we'll use the fundamental vector equation, I guess you could call it, which is that to get from A to B, you do OB minus OA. So that would be 4, 2, minus 5 minus 3, 2, 0. And that would give us 1, 0, and minus 5. Okay, great. So we can then work out the magnitude of that, which is going to give us the length, by squaring each component, adding them together, and then square rooting. So there's no point doing the 0. That gives us 0, of course. So there we go, we get root 26 is the distance AB, or the length of that line. Okay, great. Right, now let's look at part B. Now it says that we've got a position vector P, so I'll write that in column form as well, just to keep it consistent. So OP is PI, and then there's no J, and then minus 3 is the K. Okay, and it says that P lies on the circumference of the circle, of which AB is a diameter. So let's just do a quick sketch, just to get our heads around what's going on. So we've got the circumference, we've got a circle, we've got AB as the diameter, which means that it passes through the centre, and we've got P somewhere on the diagram. In fact, there's actually two possible values of P, because we know that the K component is minus 3, so perhaps P could be like here, or perhaps P could be here. Okay, so there's two possibilities, but what we do know is that the distance from CP is definitely going to be the same as the radius, because it's the centre to the circumference, and we know that distance because we know what the diameter is, so we can just half that. So if we can get a vector for CP, then we can work out its distance. Now the centre, we can find the centre by doing the centre C. We can do is equal to the midpoint of AB. And how do we find the midpoint then? Well, it's exactly the same as we would in 2D. We take each component and we average them, so we add them together and then half them. So the midpoint of AB, let's take the I components, 3 and 4, and then let's half those. So 3 plus 4 halved. Then the J components will be 2 plus 2, and we'll half that. And then the K components will be adding 0 and minus 5, and then we'll half that. So the centre is at the coordinates 7 over 2 2 and minus 5 over 2, which means the position vector is just the column of that. So 7 over 2, 2 and minus 5 over 2. Okay, great. So now we can work over here and we can find the vector CP. So C to P is OP minus OC, which is P 0 minus 3 minus OC, which is 7 over 2, 2 and minus 5 over 2. So that gives us P minus 7 over 2 minus 2 and, don't get this wrong, minus a half. Yeah. Okay, great. So now, it's a lot of work for 3 marks. The magnitude of CP is going to be each of these components squared, like so, and then all square rooted, and that will equal the radius, which is the square root of 26 over 2. Okay, so we can get rid of the square roots, like so, and in fact what we could do is we can just square this out, can't we? So that gives us 4 plus a quarter is equal to, and when we square root this, when we square both sides, we're going to get 26 over 4, which is the same as 13 over 2. Yeah. Okay, so this gives us P minus 7 over 2 squared is equal to, let's just do that over here, 13 over 2 minus 4 and minus a quarter. That gives us 9 over 4. Okay, that's good. Okay, so we need to finish it off over here, which means that P minus 7 over 2 is equal to plus minus 3 over 2, which means that P is either equal to, well, it's either equal to minus 3 over 2 add 7 over 2, which is 4 over 2, which is 2, or it's 3 over 2 add 7 over 2, which is 10 over 2, which is 5. So P is equal to 2 or 5. Question number 3, we've got 2 curves, and it says that given that the 2 curves meet at a single point, show that this is this. Well, if curves are meeting, we can solve simultaneously, and you can see here they're both equal to y, so we can set them equal to each other. So we get this is equal to minus 3x squared minus 5x plus k. And we can bring it all over to the left hand side, so add the minus 3x squared over, and then also add the 5x, and then also subtract the k, and that equals 0. Now, because it meets at a single point, this means that b squared minus 4ac equals 0, because there's only one single solution. Obviously, if the discriminant is greater than 0, there are 2 real solutions. Less than 0, there are none. If there's just a single one, then the discriminant equals 0. Okay, so we'll say the b squared minus 4ac is equal to 0. The b is the x's, which there are k and 5 of them. So that needs to be squared. Minus 4, and the a is the number of x squareds, of which there are 4. And the c is the constant terms, which are minus 9 and minus k, and that equals 0. We can expand this bracket out to get k squared plus 10k plus 25. And then expanding these brackets out, we get that's minus 16 times minus 9 is plus 144. And then minus 16 times minus k is plus 16k. Okay, then we can collect the k squares, the 2k terms there, which are 10 and 16, and then that makes 169. That equals 0, and that is, yeah, as required. Great. So box that up. Brilliant. Okay, part B. Hence find the coordinates of P. Okay, well, I'll go and solve that quadratic then. And we have 1, 26, 169. And we get minus 13, which makes sense. There's only one solution, of course. So it would be k plus 13 squared is the factorization. So k equals minus 13. Okay. Now it's asking us to find the coordinates of the intersection point. Well, the equation that we created for the intersection point was this equation right here. So this is the equation that we need to solve. So we need to solve 4x squared minus 13x, sorry, because k is minus 13, plus 5x, sorry, minus 9, and then minus k, which is minus 13, which is plus 13. So this is the equation that we need to solve. So we can simplify that down to get minus 8x and then plus 4 equals 0. This can be neatly divided through, and then this one clearly gives us an answer of x minus 1 squared when factorized, so x is equal to 1. And now we need to go back and substituting, because it says find the coordinates of P, so we need to find the y coordinate as well. Let's just use the top one, no reason to, either would be fine. So we know that y is equal to x squared minus 13x plus 9, I think it was. Let's just double check that. Oh no, it's minus 9, but k is minus 13, so that's why it's minus 13x, and then it's minus 9. So we can say that y is equal to, substituting in x equals 1, we'll get 1 minus 13 minus 9, which is equal to minus 21. So therefore P has the coordinates 1, minus 21. Proof by contradiction. We always start a proof by contradiction by assuming the opposite. So I'm going to say assume that there are integers a and b such that a squared minus 4b minus 2 equals 0. Okay, so our proof can start by, well, it says here that you can use the fact that if n squared is even, then n is even. So that gives us an idea that we need to go down the odds and evens route. So let's isolate a squared by writing it as a squared is equal to 4b plus 2. And then it says, look, n squared is even, so that gives us a clue that we need to state that a squared will be even, which it will be because we can write a squared is equal to 2 lots of 2b plus 1, and as b is an integer, it means that this right hand side must be an even integer because it's 2 lots of an integer. So we can then say that hence a squared is even. And that allows us to then imply that a is even, because we've been told that we're allowed to do that. without proof. So hence a squared is even, which implies that a is even. So let's just put that implication symbol in here. So that implies that a is even. Okay, so that allows us to write a as two lots of a different letter, where k is an integer, because all evens can be written like that. Okay, so let's then square that to get us a squared, which would look like this. So it'll be 2k squared, which gives us 4k squared. Okay, so now we've got because we know a squared is even, we can essentially and we know that a is even. We can write it as 2k, and then we can write a squared as 4k squared, and then we can substitute this back into the thing that we're trying to disprove, and that is that if a squared, which we could write as 4k squared, is equal to 4b plus 2, then are we going to come to a contradiction? So we can then write 4b is equal to 4k squared minus 2, and then we can divide through by 4 to get k squared minus a half. Okay, now this is a contradiction because we initially said that b was an integer, and if k is an integer, which we said it was, you square it, that will be an integer as well, of course, and then minus a half will not be an integer. So this is a contradiction, as b was stated to be an integer. And then the final thing we do is have to write hence, like the statement is true. But I'm going to write it down anyway, because I just don't want to give the examiner any reason to deduct any marks. So I write blah 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 has no integer solutions, A and B. Yeah, that's exactly right. Okay, has no integer solutions for A and B. Perfect. Exponential modelling, question 5, part I. In a science experiment, a substance is decaying exponentially. Its mass, m grams at time t, is given by this. Find the time taken for the mass to decrease to half its original value. Okay, so we're going to start off with t equals 0 to work out its original value. So at t equals 0, we get m is equal to 300 e to the 0. Anything to the power of 0 is 1, so it equals 300. So what we then need to do is half its original value will be m is equal to 150. So we set that equal to the equation for m, which is given as so. Then we divide both sides by 300, so we get half is equal to e to the minus 0.05t. We then take natural logarithm of both sides, which will cancel the e, and it will bring the power down, like that. Okay, and then finally we can just simply divide through by that negative decimal there, like so, to get t, and then we can just put that into our calculator. So we can do ln of 0.5 over minus 0.05. Okay, great. We get 13.9, and that will be minutes, making sure giving the units. Okay. So a second substance is decaying at also decaying exponentially, and its mass was 400, and after 10 minutes its mass was 320. Okay, so we can write that the let's call the second one n, and it's decaying exponentially, and it starts at 400, so we can write 400 e to the kt, like so. Because 4 is the initial amount, just in the same way that this equation here had 300 as the initial amount, and then you have e, and then to some coefficient of the t. Now I do know that k will be negative, so some people might want to put a negative in there and that way, but I know that k will be negative, and whatever we find it out to be, it's going to be negative, so it doesn't really matter if you put a negative there or not. Okay, so that's n, and what we can do now is we can work out k by this information where it says that after 10 minutes the grams was 320. So using t equals 10 and n equals 320, we can get that 320 equals 400 e to the 10k, like that. So we can have that e to the 10k is going to equal 320 divided by 400, which is 0.8, I think. Yeah, 0.8. Okay, so we can then say that 10k is equal to ln of that 0.8. So k is equal to 1/10 ln of 0.8. Okay, and that will be negative because ln of a number less than 1 will give us a negative. Okay, that's helpful. Now what we need to do is we need to work out the rate being the same. Okay, so we've got two equations, and we need to work out their rates, because it says to find the time when the substances are decaying at the same rate. So to do that, we can work out dm by dt by differentiating the expression for m. And when you differentiate a exponential function, the derivative of the power, which is minus 0.05, will come down, multiplied by the coefficient, essentially by the chain rule. So when we do that, we get minus 15. So that becomes minus 15, and it'll be e to the minus 0.05t. The power doesn't change when you differentiate exponentials. Okay, and then let's differentiate our expression for n. I'm not going to substitute in k. I know what k is. I'm going to save that to the end to sub again, because otherwise it's just going to be a real nightmare to write it all down. So let's just differentiate this. And again, the derivative of the power here will be just k. So that will come down. So it'll be 400 k e to the kt. Okay, now these two things need to be set equal to each other, because it says that we want the rate, which is the derivative, equal to each other. So I'm going to set that equal to this, like so. Okay, so now what I want to do is I want to isolate the exponential term, because that's got the t in it. So what we're going to do, let's just divide through by 400k. So we'll get this. So that will just give us e to the kt there. And then if we divide through by e to the minus 0.05t, then this will give us this. And hopefully you can see the reason why I've done that is that now we can write this as a single e power. Because when we are dividing through, like so, we're going to get e to the, well, we're going to subtract the powers, because the bases are the same, you're dividing them, so you subtract the powers, which gives us kt plus 0.05t. And in fact, what we could do over here as well is we could just do, let's do 15 divided by 400, and that gives us 3 over 80. So let's simplify that down to 3 over 80. So that's equal to 3 over 80k, like that. Okay, great. So now we can take the natural logarithm of both sides, like so, and that will bring the powers down, cancel the e, so we end up with this. Okay, next we can factorize the right hand side because we want to make t the subject, so we can get t come out and it's k plus 0.05. So we get t is equal to ln of this, and then divided by this. Okay, so that can go in our calculator. And now, as well, maybe you can see why I've not subbed in the k until right at the end, because it's just been an absolute mess and a real disaster. So we're going to go into here and we're going to just put that into the calculator. So what I'm going to do first is I'm going to do 1/10 of ln of 0.8. That's our k value. So that's just going to go as the answer button now. So then when I sub in for t, I can say it's equal to ln of minus 3 over 80 times by k, which is the answer button. Okay, and then that's over k, which is the answer button, plus 0.05. We press execute, and there we have it. So that's equal to 18.8 is our final answer. Perfect. Does it ask for, it says find the time, so I do need to put the units in there. So I'll just squeeze in here minutes. Perfect. Okay, log modeling. A mobile phone company records their annual sales on the 31st of December every year. Paul thinks that the annual sales can be modeled by this. Okay, let's highlight that. Okay, and then we're going to plot t against log s. Explain why, if the model is correct, the result should fit a straight line. Well, what we're going to do is we're going to take the assumed model and we're going to take logs of both sides. So we have s is equal to ab to the t, and we're doing log base 10 as it says here because that's going to be one of the variables. So log base 10 of s is equal to log base 10 of ab to the t. Now we can use log rules to split this up because we've got two things multiplied together. So we can write this as log a and then log b to the t added together. That's a standard log rule. You can't bring the power down yet because the power t is affecting the b and not the a as well. So that's why we split it up first, and then you can bring the t down. So we can write this as log base 10 a plus t, bring that down like so. Okay, and then what you need to do is you need to write it so that the it's in y equals mx plus c form. Now the two variables are the ones that I've highlighted in blue here. So these are going to be your y and your x. This is going to be the y on the vertical axis. This is going to be your x on the horizontal axis. So we're going to write it like this: log 10b times t, just swapping those two around, and then writing the log base 10a there. And that way we can pair it up because we've got the two variables on each of the axes. So we said that was a variable and that was a variable, so that's the y and that's the x. And then we've got the constants here, which is going to be, that's going to represent the m and that's going to represent this c. Okay, so we've lined it up and it matches perfectly with y equals mx plus c. It says explain why, and we can see that you can just write here hence the equation fits a straight line with variables log 10 of s and t. Okay, always like to write a little conclusion when it's explain that question. The results lie on a straight line of best fit with the gradient is equal to this and the intercept is equal to that. And now we need to work out those particular values. Okay, so let me just draw a line down here and we'll do part B on this side. Okay, so for part B then, we know that the gradient of 0, 1, 4, 6 is equal to, well, you can see here, matching it up, the gradient is log base 10 of b. So log base 10 of b. And then we can write this as a power equation, so we can say that 10 to the 0.146 is equal to b, which is equal to, it says give your answer to, what does it say? 2 significant figures, so we'll just have to do 10 to the power of 0.146, and to 2 significant figures, that is 1.4. Okay, perfect. And then the intercept is 0.583, and the intercept is the c of y equals mx plus c, and that lines up with log base 10 of a. So writing this as a power equation rather than a log equation says that 10 to the power of that is equal to a. So we can just go to our calculator and type that in. So it's 583, and then to 2 significant figures, that is 3.8. Okay, perfect. And on to part C, where it says use the model to predict the year in which annual sales will first be greater than 200 million. Well, we can use this formula here. So the sales is in millions already, so we just need it to be greater than 200. So sales is AB to the power T. So we need AB to the power T to be greater than 200. Now A is 3.8, T is 1.4, B is 1.4, and then to the power T, and that needs to be greater than 200. Okay, so 1.4 T needs to be greater than 200 over 3.8, like so. And then we could do we could write this as a log equation. So we can say that log of 1.4 to the power T needs to be greater than log of 200 over 3.8. We could bring the T down like that and say that needs to be greater than this. And then finally we can divide through, so T needs to be greater than, so dividing through, we can do that on our calculator here. We can use any log here as long as we keep it consistent. So we can do 200 divided by 3.8, close brackets, over log of 1.4. It's annoying. Why do we need to close the bracket on that when it's a fraction? Okay, there we go, 11.8. Okay, so what does this imply? It implies the year then. It means that T needs to equal 12, which means the year is going to be 12 years from the start date, and the start date is 2015. So add 12 is 2027. Okay, perfect. There we go. And then part D, it says, give a reason why this prediction may not be reliable. Well, you've used data from 2015 to 2019. If you make predictions in the future, that's called extrapolation. So we can state that as an issue. So we can just simply say, for part D, it uses extrapolation and the trend may not continue in later years. Okay, there we go. Perfect. Okay, log equation. We can see we've got 3 terms here, and one of them is not written as log base 3, so let's change that. Let's write this one. So 4 is log base 3 of 81, because 3 to the power of 4 is 81, so log base 3 of 81 is 4. And that's equal to log base 3 of 2x minus 1. Now this left hand side we can combine into a single log before we can get rid of the logs, as it were, by doing that. Now both sides is log base 3 of something. It means those somethings must be the same. So we can get rid of the logs there. And then we can times through by 81 to get as follows. And then we can write that as 86 on that side and 161 on x on that side. So x is equal to 161 over 86. No, classic mistake that. Caught that early, which is good. It's 86 over 161. Okay, there we go. Right, what's the next then? So we have a power equation there. So we have 3 to the power of something times 2 to the power of something equals 181. No, 108. Sorry. So we need to do we need to split 108 into its prime factors. So that is the same as 2 and 54, 2 and 27. Okay, right, so I think I've got it now. So we can say that 3 y plus 3 times 2 1 minus 2y is equal to, and 108 we can write as 2 to the power of 2 times 27, which is 3 cubed. Okay, great. So all right, yeah, so what we can do now is we can divide both sides by 3 to the power of 3, like so, and divide both sides by 2 to the 1 minus 2 to the y, like so. Okay, so here the powers will subtract, so y plus 3 over minus 3 is just 3 to the y. And here again the powers will subtract, so 2 minus 1 is 1, and then minus 2y is 1 plus 2y, like so. We can write this as 3 to the y, and then this is the same as 2 times 2 to the 2y. So that's where the 2 comes from. And now, gosh, this is tricky. Right, so we could write this one as 2 times 2 squared to the y like that, because, well, 2 to the y, we could write it as to the power 2 and then to the power y, because you'd multiply the powers there, and that would give you 2y. So 3 to the y is equal to 2 times 4 to the y. Now we can divide through like so. And then when you have a fraction like that, where you've applied a power to both the numerator and the denominator, we can write the fraction inside a bracket and then apply it to the whole part, like so. Okay, and that is 0.5 to the power of y. So we can write this as 0.575 to the power y equals 2. Okay, and then to finish off, it says hence find y to 3 decimal places. Well, we can write this as a logarithmic equation rather than a power one. So we can say log of base 0.75 of 2 will equal y. So y will equal, so we'll just go to our calculator and we'll type in this button here, so log, where you get to choose the base of that, equals of 2. We get minus 2.41 to 3, no, it says give your answer to 3 decimal places. So that should be 0.409. Okay, great. There we go. Tricky indices on that one. Okay, I've got functions, and it says find f of g of 5. So we'll start by finding g of 5. So we'll say g of 5 is equal to, well, just substitute in 5 into the g function, which gives us 10 minus 7, which is 3. So f of g of 5 is the same as f of 3. So substitute 3 into the f function gives us 5 minus 3 over 3 lots of 3 plus 2, which would be 2 on top and 11 on bottom. So 2 over 11 is our answer there. Okay, and now we'll go to part B. Find the inverse function of f. So what we do is we set it equal to y, and then we do an xy transpose, which means we swap the x's for the y's and the y's for the x's, which essentially reflects the function in the line y equals x, and thus creates the inverse function. So we need to now make y the subject, so we're going to rearrange, just like at GCSE, we're going to find the subject of y, so we're going to bring all the y terms over to the same side and all of the non-y terms over there, which will allow us to factorize, and then that will allow us to divide through and isolate y, like so. And in fact that is now can be labelled the inverse function, so f to the minus 1 of x can be labelled like that. And we also, as a little quirk, you also have to write the domain of the inverse function. So the domain in this case is that it can be any number other than a minus a third, because you can see here you can't substitute in minus a third because it makes the denominator equal to 0. Also, we can look up at the original function, and there's no restrictions on that. You can sub in pretty much any number other than this one, because that makes the denominator 0. So any number really can come out of this function other than minus a third. That's the one that can't come out, and that's the one that we need to exclude from the domain of the inverse. Okay, we're going to draw a big line down here, and then we're going to look at part C, which is asking us to solve this equation here. So we need to sub in 1 over a into f. So we get 5 minus 1 over a over 3 lots of 1 over a plus 2 is equal to g of a plus 3, so that means we sub in into the g function for x a plus 3 like so, and then there's also the minus 7 there. Okay, so what we could do with this fraction here, we could times top and bottom by a to get 5a minus 1 over 3 plus 2a. And then we can expand this to get 2a plus 6 minus 7 is just going to be minus 1. Okay, and then we can bring this up by multiplying both sides by that denominator, like so. And then we can expand out those brackets to get 4a squared plus 6a minus 2a minus 3. And then we can collect like so, and then we can set equal to 0, minusing the 5a over and then adding the 1 over, like so. And then we can just go to our calculator here. Let's go down to equation, polynomial solver, 4 minus 1 minus 2. Okay, and we're going to get that a is equal to 1 plus root 33 over 8, or a is equal to 1 minus root 33 over 8. And let's just double check, are any of those solutions not valid? Well, it says that x can be any real number substituted in other than this one here, but it's not that. So both of these are valid. Question 9, geometric sequences with a little binomial year 1 for good measure at the start. It says find ascending powers of x the second, third and fourth term. Second, third and fifth term. Okay, so second, third and fifth term we need to find. Okay, so remember the first term is when you would do 6 choose 0. So the second term will be 6 choose 1, and it will be ascending powers. So we start with the earliest power of x, which is just a constant term, and then for the second term it will be the x to the power 1, and then the 3 will need to be raised to the power 5 so that the powers add. So the third term will be 6 choose 2. It will be x to the power 2, and it will be 3 to the power 4, because again the terms need to add. And then the fifth term, which is actually second to last, so it's 6 choose 4, and then it's 2x to the power of 4, and then 3 to the power of 2. Okay, so I can see why students might make a mistake here, because you might think the second term happens to be the x squared term, but of course when you expand it out you get a constant, then you get an x, then you get an x squared. So in fact the x squared is actually the third term. Okay, so what we're going to do is we're going to go to catalogue, probability, and we're going to go to combination. So we're going to do 6 choose 1, and we're going to then multiply that by 2, and then we're going to multiply that by 3 to the power of 5, and that's going to be 2916, and there'll be a single x there. Okay, then for the next term that we need, that's going to be a 4. That's going to be to the power of a 2, and that needs to be 6 choose 2. So that's 4860, and that will be x squared. And then this one is going to be a power 2. That's going to be a power 4. and that is going to be 4. So we get 2160, and that'll be x to the power 4. Okay, great. It says for a particular value of x, these three terms form consecutive terms in a geometric series. Find the value of x. Wowza. Okay. So what that means is if they form a series, then you multiply by r, and you get from one to the next. So we can find an expression for r. In fact, we can find two expressions for r. By reversing this process, we could say that it's the last term divided by the one before it. That gives us what r should be. Like so. And also, it is the middle term divided by the first term, like so. Okay, so let's do some simplifying. So the left-hand side can be simplified down to get 4/9 x squared, because x to the 4 over x squared is just x squared. And then the right hand side can simplify down to 5/3 x, like so. Now we can assume that x doesn't equal 0, I assume, for a particular value of x. Yeah, because if x was 0, then it wouldn't really be a geometric series. It would just be 0, 0, 0. So we can divide through by an x without being too worried about losing the solution that x equals 0. And then we can find x then by doing 5/5 divided by 4/9 to get 15/4 as our value of x. Okay, let's move on to part 2, and it says in a different geometric series we have all of this information here. Show that it's equal to, we get an equation like that. Okay, so let's just come down here and we can say that for part 2 we know that the first term is sine squared theta. We know that r is equal to 2 cos theta, and the sum to infinity is equal to 8/5. We also know that the sum to infinity is equal to a over 1 minus r, and that's given in your formula book. So we can say 8/5 is equal to sine squared theta over 1 minus 2 cos theta. Right, we can then cross multiply. So we get 8 minus 16 cos theta when we multiply that denominator up by the 8. Then we times the 5 over that side, like so. And then of course we can use the fact that sine squared plus cos squared is equal to 1. So sine squared is equal to 1 minus cos squared. And then we can expand out these brackets like so. And then we can add the 5 cos squared over, keep the minus 16 on that side, and then minus 5 to make 3 on that side equals 0. And I assume that is the thing which we were looking for. Okay, so let's just double check that. Yes, and it says hence find the exact value of the second term in the series. Okay, so exact value, and so let's solve this quadratic. So let's just do that on our calculator. So we're going to go to equation, polynomial, and we're going to solve 5 minus 16 and 3. We get x equals 3 and a fifth. Okay, so for part B, we get, when that is factorised, we get 5 cos theta minus 1, and we get cos theta minus 3 equals 0. So cos theta equals a fifth, and cos theta equals 3. And obviously this one has no solutions, so we can ignore that. Because cos theta can't equal 3, because it has to be between minus 1 and 1. So we know that cos theta equals a fifth. Okay, great. Now the question is asking for the second term. So a2 is equal to a r to the power of 2 minus 1. Because we know that any term in a geometric sequence is equal to a r to the position minus 1. So the second term will just be a r to the power of 2 minus 1, which is just 1. So we need to work out the second term, and it's the first term. And remember, the first term was sine squared, and that's times by r, which was 2 cos. Okay. So what we can do is we can just draw a little triangle here, because if we've got theta in the corner and we know that cos of the angle is 1 over 5, adjacent over hypotenuse, then the opposite by Pythagoras' theorem will be 5 squared minus 1 squared square rooted, which is root 24. So that tells us that sine theta is equal to root 24 over 5. It might be positive or negative, but actually it doesn't really matter because we are finding sine squared theta anyway. So that will be 24 over 25. Okay, so we can substitute that in. It's 24 over 25 times by 2 lots, and cos theta is 1 over 5. So that will give us a total of 48 on top and 125 on the bottom. Perfect. You can do that question without using the triangle method. You can use the just sine squared plus cos squared equals 1, but that's the way I like to do it. Okay, year 2 binomial. Part A, find the first 4 terms in this expansion. Right, so let's just call this f of x. So we can say here that f of x then is equal to, well, that would be 2, and we can bring this bracket up as long as we use a negative power, because it's on the denominator, so we bring up to the numerator, use a negative power, and it's square rooted as well, so power is minus a half. Okay, now we need the constant term inside the bracket, so the non-x term, to be a 1. So what we can do is we can bring out a factor of 9 out of the bracket, which gives us 1 minus 2 over 9x. But in order to do that, really importantly, we have to bring out the power as well, like so. Okay, so if you ever have to take a factor out of a bracket which has a power, you have to bring out the power as well. So you want to divide through by 9, which we've done inside the bracket. So you've taken out a factor of 9, but you have to bring out the power as well. Okay, so we can simplify this because 9 to the power of minus a half is the same as a third. So it's 2 thirds, and then 1 minus this. Okay, now whenever I do a binomial expansion using the formula, I like to note that the n is going to be the power, and the x in the formula is actually not just a single x, it's now minus 2/9 x, like so. Okay, right, so now I can use the formula, and here it is as given in the formula book. So we can say this will be 1 plus nx. Well, I can read off from here so I don't make a mistake. And n is minus a half, and x is minus 2/9 x. And by the way, sorry, all of this is needs to be multiplied by 2/3 afterwards, so let's write that there so we don't forget. Okay, we want the first 4 terms, the question says, so let's keep going. The next term is n, which is this, n minus 1, which will be this, over 2 factorial, which is 2, and then the x, which is this, needs to be squared. Okay, and then keep going, so we need one more term, and that will be n minus 1, n minus 2, all over 3 factorial, which is 6, and then the x, which is this, whoops, needs to be to the power of 3. Then we can close the brackets there, because that's all the terms we need. Okay, so let's keep the 2/3 out for now, and then let's simplify this as much as we possibly can. So the 2's will cancel, the negatives will cancel, so this is just 1/9 x. Okay, in the next term, I just use my calculator to get this. Okay, and then the next term, I'll just change the power here like this, and then just change this to a 6, and then go up here and multiply by a minus 5/2, and that will give us the next coefficient. So that's 5/1. Oops, that should be a squared. 1458, and that'll be x cubed. Okay, great, and then we're just going to times through by 2/3 to get our final answers. So 2/3 plus 2/27x plus 2/162x squared plus it'll be 5 over, let's just times through by 2/3. Whoops. So 5/2187x cubed. Wowza. Oh, and I just spotted that this fraction here can be simplified because both of them are even. So that should have been 1/81. Because it does say give your answers as simplified fractions. So perhaps you might lose a mark for that. Okay. Right, there we go. So now let's look at part B. It says by substituting x equals 1 into part A, find an approximation from root 7. Okay, so we know that this bracket here is pretty much the same as this here. So let's sub in x equals 1 into both of them and set them equal to each other. Okay, so for part B, we're going to sub in to what was 2 over 9 minus 2, 1, and that was rooted on the bottom, like that. And we're going to say that's approximately the same as 2/3 plus 2/27 sub in 1 plus 1/81 sub in 1 squared plus 5/21871 cubed. Okay, because both of those two things, the function which we expanded, we got this, so they should be the same. So we can say that they are, roughly the same, because of course when you do the expansion there are additional terms, but that's why it's just an estimate. Okay, so what does this give us? This gives us 2 over root 7 on this side, and then this I need to put it to my calculator. Okay, I've done that, and I've got this fraction here, like so. And then I've been asked to work out root 7. So what we're going to do is we're going to take the reciprocal of both sides to flip over both fractions. And then that will allow us to show that root 7 is approximately, well, we just need to times through by 2. So I do 1 divided by the answer, that takes the reciprocal, that flips it over, and then times it by 2 gives us this. So that's going to be our estimate. Whoops, didn't read the question. I just spotted that it says to 4 decimal places. So we just need to just write that as 2.64 77. Yeah, right. I think that will be our final answer then. Recursive sequences, and we've got a sequence which starts off with u1 equals 3, and then the next term is 2 minus 4 divided by the previous term. So if we want to work out u2, u3, u4, we can say u2 is equal to 2 minus 4 over the previous term, which is 3, and 2 minus 4/3 is 2/3. So u3 is 2 minus 4 divided by the previous term, which is 2/3. And this gives us 2 minus 6, which is equal to minus 4. And then u4 is again 2 minus 4 over the previous term, which gives us 2 plus 1, which is equal to 3. And we have closed the loop because we started with the first term equal to 3, and now we have the fourth term equal to 3. So therefore we can say that this is a periodic sequence of order 3 as u1 equals u4. So if there are terms that have are spaced out by 3 terms, then we know they're going to be the same. And that's going to help us for u61, because that will equal u1, which is equal to 3. And that's because the gap in the number of terms between them is 60, and that itself is a multiple of 3, so it will loop back to the first term here. Okay, great. And now we're asked to work out the summation of the first 99 terms, starting with the first term. So 99 is a multiple of 3, so this is actually relatively straightforward in that there are 33 3's in 99, so we have to times 33 by the sum of the first 3 terms, which is 3 plus 2/3 and then plus minus 4. So that group of the first 3 terms then gets repeated 33 times, and that will make all 99 terms. So that can go into our calculator. So it's 33 multiplied by 3 plus 2/3 minus 4 close brackets, which gives us minus 11. Okay, perfect. Okay, trig identities and equations, the most high value topic in my opinion of all of the ones in the EDEXCEL Pure A level. And we are going to start with the left hand side. We notice that they are 2 thetas, and we want to convert that into just a single theta, so we're going to have to use the double angle formulas. We're going to times the 2 into that bracket, like so, and then on the bottom we've got cosec squared 2 theta, which is the same as having sine squared 2 theta on the bottom, like that. Okay, so that's good. Now we can swap out these double angles. So cos 2 theta has 3 different versions that we could use. We could use this. We could swap those out and use this. Or we could swap out and use this. Now I recommend memorizing all 3 of these. I'm going to pick the one that includes sine squared. Because we've got to convert to a tan in the end, and tan is sine over cos. So having a sine on top, I think is going to be very helpful. Also, we're taking away, so we're 2 take away, and then when we expand this bracket, we'll have 2 take away 2, which will cancel out, which will be also helpful. Okay, on the bottom, we've got squared, and sine 2 theta is 2 sine theta cos theta, and then that needs to be squared. Okay, so like I said, when we expand these brackets out, the 2 and then minus the 2 that's going to come out when we expand that bracket will cancel. So we'll just be left with minus 2 times minus 2 sine squared, which gives us 4 sine squared theta. And that's going to be over, well, 2 squared is 4, sine squared is sine squared, and then cos needs to be squared, so cos squared. Okay, great. So that cancels out, which just leaves 1 over cos squared, because the 4 cancels and the sine squared cancels. And that can be written as sec squared theta. And then we can use the identity, which comes from cos squared theta plus sine squared theta. You don't need to prove this identity, by the way. But if you divide each of these by a cos squared, then that gives you 1 plus tan squared theta equals sec squared theta. Okay, so you can just swap that sec squared theta out for 1 plus tan squared theta, and that is the right hand side. So that is proven. Perfect. Okay, now it says hence solve between 0, x 360. This equation, and we notice that in fact this is a direct swap, so this side of the identity is exactly the same as that, as long as you swap the x for the theta, which is no problem. So therefore these two sides must also, we can set those two equal to each other as long as we swap the x for the theta. Okay, so let's do that here then. So the identity said that it was 1 plus tan squared, and then here we've got 4 plus 3 sec squared. Sorry, just 4 plus 3 sec x. Now, we want to convert this into just a single trig function. And we've just shown that 1 plus tan squared is the same as sec squared. So let's just swap that out then for sec squared x, like so. And then we bring it all to one side to create a quadratic in sec x, like so. And then we can factorize that quadratic to get sec x minus 4 and sec x plus 1. Okay, that gives us then sec x equals 4 and sec x equals minus 1. Then we can take the reciprocals of both of these two equations, because the reciprocal of sec x is cos x, and the reciprocal of 4 is a quarter, and the reciprocal of this is just minus 1. Okay, so we get x equals x equals. So we need to check, are we in degrees or radians? We're in degrees. So we have to go to our calculator and just change that to degrees. And then we do inverse cos of a quarter. And that gives us our first solution. And then the second solution will be 360 minus that, because for cos, the second solution is always 360 minus. Sine it's 180 minus, tan it's 180 plus. So that gives us 284.5. And then inverse cos of minus 1 is equal to 180. Brilliant, 180. And there we have it. Those are our free and only solutions. Perfect. Question 13, trig modelling. And I'm going to use my little shortcut method for this. And that is that because we are going into cos, we can label the coefficient of the cos A, and sine will therefore be B. So the value of R is always the square root of A squared plus B squared. And that is 5 squared plus 3 squared, which is the square root of 34. Don't know why that took me so long. And then alpha is always inverse tan to the minus 1, so inverse tan of B over A, which in this case is inverse tan of 3 over 5, which equals, is it in degrees? No, it's in radians. Annoying. There we go, change it to radians, and it says to 4 decimal places. Okay, better grab a bit more space then. So that is equal to then 0.5404. Okay, great. And then it says the height of the seawater on a harbour wall is modelled as that equation. Okay, and then we need to compare that equation to the r cos theta plus alpha that we've converted to. So we can start by writing that h is equal to, we've got this extra 6, and then this bit here, well, the coefficients have been halved. You can see that 5 has turned into 2.5, 3 has turned into 1.5, so it's going to be 1/2 of, and then we can use the transformation here. So we can say r, which is root 34, cos, now the theta has now converted into a 4 pi t over 25. So we say cos of 4 pi t over 25, and then it's plus alpha, so plus 0.5404. Okay, so there we have it. Now we've written that equation out with just a single trig function, which is really helpful because it means we can solve that equation if needed, which I'm sure we will. Okay, calculate the times at which the model predicts the height of the seawater on the harbour will be 4.6. Give your answer to the nearest minute. Okay, so we're setting this equal to 4.6, aren't we? That's what we're doing. Okay, so we can then say cos of this horrid thing is equal to 4.6 over oh, actually I've jumped the board here, so just subtract 6 first, get the 6 off both sides, and then we can divide by 1/2 and by root 34. Okay, great. So let's actually work what that is. Let's just write that down. So 4.6. Yeah, we've had to first subtract the 6, and then we have divided it by 1/2, and then we've divided it by the square root of 34. Okay, Okay, I guess that's a little bit neater. So it's that over 85. Okay, great. So now we can do inverse cos of that. Okay, so we do that, and that's equal to inverse cos of this. Okay, and then we can start reeling off our answers. So if we do shift cos of that, we get our first one is 2.07. Yeah, that should be enough accuracy, I believe. And then, in fact, let's just give it one more decimal place, just in case. So put 2. And then the second solution for cos is 2 pi minus. So we'll do 2 pi minus the answer, which gives us 4.212. Now we could, we might want to start solving for t now, but there could be additional solutions. Now, it does say that t is between 0 and 12. So, what would 4 pi t over 25 plus 0.5404 be between then? I hear you ask. Well, if you sub in 0, you get 0.5404. So that's the lower bound. And then the upper bound you would get by doing 4 pi times 12 divided by 25 plus 0.5404, which is 6.57. Okay, so will this give us another solution if we add 2 pi to it? Because remember, you can always add 2 pi to solutions. Well, that's going to be too much, isn't it? Yeah, that's going to be too much. So we know actually there's only these two solutions. So we don't need to find any more. Okay, so then we just need to solve for t. So I do that by doing this. We need to write it in a fraction, and we're going to take that, we're going to subtract 0.5404 from it, and then we're going to divide by 4 pi over 25. Okay, so that's going to solve the equation for t using this value here. So subtract that over, then divide by the 4 pi over 25. Okay, great. So that gives us 3.047. And then for the other one, we just need to go, we just need to go over here and change this number to 4.212. And that gives us 7.30. 4. Now it says calculate the times, and t is the hours after midday, and it says to the nearest minute. So if this is 3 hours after midday, so that is 1500 in terms of 24-hour clock, and this as a minute would be, you times through by 60, which tells you that is 3 minutes, so that's to the nearest minute. And then 7 hours after midday is 1900, and then 0.304 in minutes is 18 minutes. It's the nearest minute. So those are my 2 times of day. Perfect. Okay, parametric integration, and we are looking to integrate between these 2 points because we need to find the area enclosed. So if we draw lines down where we're trying to enclose the area in terms of x, it would be between these 2 lines. So we need to work out the t value at each point. Now we know at this point here, x equals 0. At this point here, y equals 0. So we need to find, again, because we're integrating with respect to t, we need to find the t values, or at least we need to show that they are going to be equal to this for the limits. So we're going to sub in, so the first one was when x equals 0. So we say x equals 0, which is the same as 2 cos 2t, which means cos 2t equals 0. So 2t is equal to inverse cos of 0. So 2t is equal to pi over 2. So that's why t is equal to pi over 4. And then when y equals 0 for the other one, we know that's equal to 4 sine t, which means that sine t equals 0. So t is equal to inverse sine of 0, which is 0. So we'll just leave it like that. Okay, so those are the 2 limits. Notice as well that the limit on the right, which is the upper limit, is actually the 0, and the limit on the left, which is the lower limit, is the pi over 4, unlike what it is here. But I'll show you how we can swap that round. So we know r is equal to the integral of y dx by dt. So that's the formula which we need to remember for parametric integration. So let's go ahead and find dx by dt then. So we can differentiate this. Cos differentiates to minus sine, but it's cos 2t, so we times by the derivative of the input, which is 2. So it would be minus 4 sine 2t. So that means that r is equal to the integral between, like I said, the limits were actually this way round. And it is y, which we know is 4 sine t, multiplied by dx by dt, which is minus 4 sine 2t dt. Okay, and then we can flip the integral over by getting rid of the minus, because if you integrate f of x between b and a, it would be the same as integrating minus f of x between a and b. So you can swap the signs over as long as you take out a negative from the integral itself. So it becomes 4 sine t times, and then we could do 4 times by sine 2t, we know is 2 sine t cos t by the double angle. Okay, so this is therefore equal to the integral between pi over 4 and 0. 4 times 4 times 2 is 32, and we've got a sine squared t, and we've got a cos t dt. Okay, perfect. And now we need to integrate, and we need to use the reverse chain rule here, which I cover in loads of detail in my Easter integration masterclass session, which you can pick up a recording for if you missed that. I would recommend it, of course. So what I notice is that you have a sine function to the power, and the derivative of that function is multiplied next to it. So that means we can use the reverse chain rule. So I take that sine function, and because it's squared, and I'm going to integrate, I'm going to just up the power to a power 3. like so, and then I'm going to divide by the new power, and I'm going to divide by the derivative of the bracket, or the derivative of the function, should I say, which is sine, and that differentiates to cos. Now the reason why we can do this is because there is a cos multiplied next to it, and when we do that, it just cancels out. Okay, so there we go, nice and quick. Like I say, this is just a quick fire method of being able to do reverse chain rule, and if you want to learn more about that, yeah, check out my revision masterclass session. Okay, and then we've got pi over 4 and we've got 0. So we just need to now just substitute into this then, and subbing in sine of 0 is 0, so it's just the pi over 4 that we need to sub in. So it's 32 over 3 sine of pi over 4 cubed is going to be our answer. So I'll put that into the calculator, and there we go. Just being careful about subbing it in, we get 8 root 2 over 3 as our final answer. Okay, another high value topic, chain and quotient rules. To work out the derivative, we're going to start by writing u as the numerator and v as the denominator, like so. And then u dash with respect to x is 2, and v dash, well, by chain rule, the power comes down to the front, keep the bracket the same, drop the power down by 1, and then times by the derivative of the bracket. And the half and the 4 will times together to make 2. Yeah, and if you need any additional help on differentiation, chain rule, product rule, quotient rule, and all that stuff, check out the session that I did over Easter, 3-hour session, and I go through everything I know about differentiation, loads of shortcuts and little handy tricks. Okay, so now we can work out the derivative by using the quotient rule, and that will be v times by du, so times that by 2, minus u times by dv, which will be this, and that will all be divided by v squared, which will be 4x minus 1. But yeah, by the quotient rule, perfect. Okay, now it says simplest form, so we're going to want to try and collect the top up as much as possible. So to do that, we're going to multiply through by 4x minus 1 to the power of a half on both the top and the bottom. Okay, so why do we do that? Well, when you times through by the root of something which is already the root, then it's just going to be whatever that something is. So it's going to be 2 lots of 4x minus 1 now, there. And when you times by the negative power times by the positive power, well, they're going to add together to make a power of 0, which is just 1. So essentially that bracket there just completely disappears. So it'd just be 2 lots of 2x plus 3. And then on the denominator, we do need to multiply that by a power of a half. That's already to the power of 1. So times it by a power of a half means you add the powers together. So it'll be 4x minus 1 to the power of 3 over 2, like so. Okay, and then how many x's we've got on top? We've got 8 minus 4 when you expand out, so that gives us 4x. And then you've got minus 2, and then minus 6, which is minus 8. Okay, great. And then I guess just to finish off, we could take out a factor of 4 as well. Like so. Right, so that will be our final answer in its simplest form. Okay, and now part B, we need to hence find the range of f of x. Well, if we had a graphical calculator, we could sketch the function and it would look like this. And you could tell that there's a minimum point here, and it's going to go up all the way off to infinity over there. So it's going to be between whatever that minimum value is up to infinity. So just greater than or equal to that minimum value. But how could we prove that on just without having a graphical calculator? Because I know most people don't. Well, what we could do is we can find the minimum point by using the gradient function, which we've already calculated. So minimums happen when f dash of x equals 0. So to make this fraction 0, the numerator needs to be 0, which means that x would equal 2. So if I sub in 2 into the original function, that will tell us what the minimum value is. And when you do that, you get root 7. But how would you know that was the minimum as opposed to the maximum? Well, you can see here that x is bigger than a quarter. So obviously we can't sub in a quarter, but we could sub in just slightly more than a quarter. So when you sub in slightly more than a quarter, the denominator is really close to 0. Really close to 0. And when you divide by something which is really close to 0, you get a massive number. And in fact, there's no limit to how big a number you can get as long as you just keep getting closer and closer to 0 on the denominator. So with that being said, it can go off to infinity. So we know that this must be the minimum point. So we can say that f of x is just greater than or equal to root 7 for our final answer. Perfect. Okay, question 16, and we've got implicit differentiation. We have this equation here, and the point P lies on C and has x coordinate 2. Find the y coordinate of P. Okay, so we just need to sub in the x coordinates 2 into this equation here. So we can say for part A then, we have 2 to the 2 minus 4 lots of 2 times y plus y squared is equal to 13, which gives us y squared minus 8y, and then we're going to have plus 4 equals 13, which is the same as if we just minus 13 for both sides, we get minus 9 over here, and then that will be equal to 0. We can factorize that to get y minus 9, y plus 1, which means y equals 9 or y equals minus 1. We know that y is greater than 0, so the answer must be y equals 9. Okay, part B, we need to differentiate with respect to x to find dy by dx. So 2 to the x, this is kind of one you just need to know. It should be in your notes that a to the x differentiates to a to the x ln a. So 2 to the x differentiates to 2 to the x ln 2. And now here we've got a product, so I'm going to highlight the minus 4x in green and the y in blue. And we're going to differentiate the green, which gives us minus 4, and then leave the blue alone. And then we're going to leave the green alone, and we're going to differentiate the blue, which is dy by dx. So that's the product rule in action there. And then next, we've got y squared, which implicit differentiation tells us that differentiates to 2y, but then you have to multiply by dy by dx. And that equals 13, which differentiates to 0, so 0. Okay, great. So now what we can do is we can collect up the dy by dx's, of which we have 2y and minus 4x. And then all the other terms can go over to the other side. So the minus 4y goes over to become plus 4y, and the this term here moves over and becomes minus. Okay, great. So then we can, final step is just to divide through by that bracket to isolate dy by dx. So we have this as our derivative. Okay, great. And now it says that the tangent to C at P crosses the x-axis at Q. Find the x-coordinate of Q, given your answer is this. So the tangent to C at P has the same gradient as C does at P. So we can find that gradient just by substituting into the derivative function. So we can say part C, we can say at P, dy by dx is equal to 4, and the y coordinate was 9 at P, minus 2, the x coordinate was 2, over 2, the y coordinate was 9 again, and then minus 4, and the x coordinate was 2. Okay, so this is 36 minus 4 ln 2. Got to keep it exact because the question asks for it in exact form. Over 18 minus 8, which is the same as, let's just scroll down a little bit here. That's the same as 36 minus 4 ln 2 over 10, which we can simplify to 18 minus 2 ln 2 over 5. Okay, so that's the gradient of the tangent. Now we're going to find the tangent, the equation of it, by using y minus y1 equals mx minus x1. So we're going to say that y, and then this is the tangent at P, of course, so therefore we can use the coordinate of P as y1 and x1, and the y coordinate was 9. The gradient is this once again, and then we have x minus the x coordinate, which we said was 2. Now, that tangent, what does it do? It crosses the x-axis at Q. So that means that Q, y equals 0. Okay, so we can say at Q, y equals 0, which means we can substitute 0 into our equation. So we just end up with minus 9 equals 18 minus 2 ln 2 over 5 x minus 2. Wowza. Okay, we're going to multiply through by 5 first off. And then I think we're going to need to, remember that's in a bracket essentially, we're going to need to multiply into that bracket. So we'll get 18x, we'll get 18 times minus 2, which is minus 36. We'll get minus 2 ln 2 x, and we'll get plus 4 ln 2. This is a beast question, isn't it? Let's move all the non-x terms over to this side. So adding on 36 gives us minus 9, and then minus 4 ln 2. And that equals all the x terms, which is 18x minus 2 ln 2x. Now we can factorize an x like so, because that will then allow us to solve for x. So we've got minus 9 minus 4 ln 2 over 18 minus 2 ln 2. Wowza, that was an absolute beast question. But I hope you enjoyed that. Also, just to note, if we wanted to, we could also multiply top and bottom by a negative, which might be a bit neater, and also write it exactly how they wanted it. which would have been like that. Okay, so perhaps that is the nicest of final answers, but both completely correct. Okay, we have numerical methods, iteration, and also a little bit of product rule in here as well, because for part A it is asking us to differentiate x cos x over 3. So by product rule, what I like to do is just colour one of them in one colour and one of them in the other colour, and just imagine it as we are differentiating the blue, which gives us just 1, and then we are leaving the green alone, adding, leaving the blue alone, and differentiating the green, which gives us this, and we have to times by the derivative of the input function, which is 1/3. And cos obviously differentiates the minus sign. Okay, so then we can bring it all nice and tidy by doing that, by doing minus 1/3 of x times by sine of that. Okay, there we go. Nice. Okay, great. On to part B now. And it says, show that this derivative function equals 0 can be written like this. Okay, so the derivative function is what we've worked out already. So that's cos of x over 3 minus x over 3 sine of x over 3. And that equals 0. So the natural thing to do, because we've introduced a tan, is we're going to want to divide through by cos of the input. And we can do that because the inputs are the same for cos and sine. So if we just divide through by cos x over 3, we get 1. And then we can divide the part of this term, the sine part, by the cos, and that's going to give us tan. Like so. Okay, great. Now, it's interesting to note actually that the x is on the bottom of the tan here. So anyway, let's just move it along, and what we're going to do is we're going to say 1 is equal to x over 3 tan of x over 3. We're going to times by 3 and then divide by x, like so. And then doing inverse tan of both sides is the same as doing arctan of both sides. They mean exactly the same thing. And that will cancel the tan on the right hand side to just leave x over 3. So then multiplying through by 3 is going to give us this, which is, yeah, exactly the way that they want. So k is equal to 3. K is the integer that has been found. Okay, great. So let's box that up then. That's the end of that part of the question. We might even want to say next to it that k equals 3. Okay, great. Next, it says starting with this x value, use the iterative formula with the k found to find the values of x equal x2 and x6. Okay, so I'm just going to rule off here. And then we're going to say, so for part C, we're just going to need to substitute in. Now, it's 2 marks. You just have to find them basically. So there's no working out marks here. We just have to give it correct to 3 decimal places. So we go to our calculator. We check and we make sure we are in radian mode, as by default. If you're working any trigonometry, it will be radian mode. So we go to 2.5, we press, that's our answer button, and then the formula is 3, arctan is the same as, tan to the minus 1, and then fraction 3 over the previous x value, which is actually our answer. So press equals, and that is x2. And we want that to 3 decimal places, so 6 to 8. So that's x2, we press equals again, that's x3, equals again x4, equals again x5, and finally equals again, that would be x6, which is what they're after. So 2.586. There we go. Great. Now it says using a suitable interval and a suitable function that should be stated, show that a root of the derivative function is equal to that, correct to 3 decimal places. Okay, so the function is the derivative function, because that's what we're solving equal to 0, and the derivative function is this. So we're going to have to, it says that that should be stated, so I will write that down again. We're going to be using the derivative function, which is this, and we're going to find the upper and lower bound of this interval and prove that there is a change of sign, hence the root is there. So the lower bound is 2.5805, and we will substitute that in. Okay, I've subbed that in and I've got a positive number, 0.000347, which is greater than 0. And then I'll need to sub in the upper bound, which will be this. So I'll do that now. Okay, so I've just done that, and we get a negative number, which is great, because that's less than 0. And then we can say, hence, as f dash of x is continuous, and there is a change of sign, the root is 2.581 to 3 decimal places. Perfect. Okay, we have a differential equation question coming up. Water flowing into a large container, water starts to flow, blah de blah de blah. Solve this differential equation. Okay. So the first thing we do to solve a differential equation is we multiply through, in this case, by dt, and that's going to give us this. So that means that the right hand side is where we're going to have the t variables, and the left hand side is we're going to have any variable with v. So we're going to actually divide through by that 300 minus kv dv, and that will equal just 1 dt on that side. Then we can integrate both sides. Okay, great. Now, in fact, I'm going to rewrite this side as, because I really want the numerator of this fraction to be the derivative of the denominator, because then I can just integrate straight to ln of the denominator. So the derivative of the denominator is minus k, so I really want just minus k to be on the top. That would be really helpful when I'm trying to integrate this fraction. But of course you can't just do that. But what you can do is you can multiply both sides by minus k, which gives us this. Okay, so just multiply both sides by minus k. Again, it's a constant. We know k is a constant. It says it in the question, so it's not going to affect the integration at all. It just makes it easy for us to do the integral, because this is going to integrate now straight to ln of the denominator. Okay, and then this is going to integrate to, well, minus k integrated to the power, integrates t, is just going to be minus kt, but plus a constant of integration. Okay, great. Now what we can do is we can do, we take e as the base of both sides, so that will get rid of the ln, like that. So we get e to the minus kt plus c, like that. We can then do a bit of moving around. So we can move this over to this side. And we can add the kv over to that side. Okay, and then we can say that v is equal to, so we can divide through by the k, like that, and we get this. Okay, so let's carry on, and we can say that v is equal to 300 over k, and then we can split up this numerator into e to the minus k times by e to the c, and it's all divided by k, but we could just divide this part by k, which is fine given that the numerator is multiplied together. We're allowed to do that. And the reason why we've done that is so that we can let minus e to the c over k equal a different arbitrary constant, because e is a constant, c is a constant of integration, and k is a constant as well. So we can just swap it out for another arbitrary constant, and we'll call that capital A. And I've taken the minus out with it as well, so that we can then just say that it's v is equal to 300 over k plus, because the minus has been taken out and taken over by a, and then it's just going to be e to the minus kt. And that is exactly what we needed to show. Okay, perfect. Okay, on to part B, and it says that we know two things. We know that initially it's empty, and we know that at t equals 10, it's increasing at this particular rate. We can work out k. Now, we can see in the equation there are two unknowns, which means we need 2 bits of information. So let me just copy the equation down here so we can use it in our working. Because we know, well, first off, we know that initially it is empty. So we know that when t equals 0, v equals 0. So we can substitute into here to get 300 over k plus a e to the 0 equals 0, which gives us that a is equal to minus 300 over k. So that's as far as we can take that part, or that information. So we'll box that up. And then we will use the fact that the other thing that we knew was that when t equals 10, dv by dt, because it said that the rate of increase of volume was equal to 200. So we'll need to find dv by dt. So we'll need to differentiate v, which we can see here. So when we differentiate this bit, it's just going to be 0, because that's just a constant. When we differentiate an e function, then we get just simply e to whatever it is, because we know that an e function differentiates to itself, but we have to, by the chain rule, times by the derivative of the power, which is minus k. So we end up with minus a k e to the minus kt. Okay, great. So we know that minus a k e to the minus, and t is 10, is equal to 200. Like that. Okay, now once again, that's about as far as we can take that bit of information. So we'll box that up, and then we'll combine the 2 green boxes in order to work out k. So the 2 green boxes, so combining them, we can say that minus 300 over k, that's a. So summing it into here, gives us, whoops, so we get minus, which is here, then a, which is the minus 300 over k, then times by k, then times by e to the minus 10k is equal to 200. Okay, great. So that is going to cancel with that, and the two minuses are going to cancel as well. And we can then divide through by 300. So we get this is equal to 200 divided by 300. So then we can take ln of both sides. So we get minus 10k is equal to ln of 2 over 3. So k is equal to minus 1/10 ln of 2 over 3. Now, what does it ask us for? Does it say the exact value? It does say the exact value, great, so we don't need to do any more on that. And then it says, hence find, according to the model, the time taken for the volume of the water container to reach 6 litres, giving your answer to the nearest second. We'll just double check. 6 litres, well, the volume is actually in centimetres cubed, and a litre is 1,000 centimetres cubed, so we need the actual volume to be 6,000. And t is in seconds, and it does say nearest second, so that's fine. Okay, so we'll box that up as our value for k, and then we'll move on to part C, and we will say that because we need 6 litres, that's equal to 6,000 centimetres cubed. So we need V to equal 6,000, and we know that V is equal to, again, let's look at our equation for V, it's this. So it is 300 over K plus A e to the minus kt. Okay, and then we can substitute in for a, so we get 300 over k plus a is minus 300 over k. So we can do minus, and again a is you can see up here a is minus 300 over k. So we can swap out a for that, and then e to the minus kt. Then we can perhaps do a little factorising here, and that's 1 minus e to the minus kt. Okay, we're going to need some more space. We can then times by k and then divide by 300. So that gives us 20k on that side, like so, because we're timesing by k and then we're dividing by 300. Yep, so that gives us 20k. So e to the minus kt is equal to 1 minus 20k. We can then take the natural logarithm of both sides, like so. And then we can divide through by minus k, like so. And once again, I've not substituted in for k just yet because it just makes so much more sense if we save it right to the end. So we can now go to the calculator, and what I'll do is I'll type out what k is, which is minus 1 over 10 times ln of 2/3 equals, so that's k. So then subbing in for t, we can say that it is ln of 1 minus 20 times by k, which is now the answer button, and that's over minus k. And there we go, we get 41.08, which is approximately, to the nearest second, 41 seconds. Wow, that was an absolute beast question. Okay, 2 more to go. And we have a graph. We've got the equation and it says find dy by dx. Okay, shouldn't be too much problem. So year 1 differentiation here. So x cubed goes to 3x squared. That's 10x to the 3 over 2. So the power comes down. 3 over 2 times 10 is 15. X, then we minus 1 from the power, so we just get a half. And then kx will differentiate to just k because k is a constant. Okay, great. So there we go. That's that part done. And part B, it says that the point P on the curve is a minimum turning point. Given that the x coordinate of P is 4, show that k is equal to minus 72. Well, we know that at x equals 4, dy by dx equals 0 as it's a turning point. So we can substitute in x equals 4 into dy by dx. So we get 0 is equal to 3 lots of 4 squared plus 15, 4 to the half, plus k. So 4 squared is 16, times by 3 is 48. 4 to the half is 2, times by 15 is 30, plus k. So rearranging that gives k is equal to minus 78 as required. Okay, great. And now part C. Okay, so part C is obviously the tricky part, and then it says that the line through P parallel to the x-axis cuts the y-axis at the point N, and then the finite region blah 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 blah. Use integration to find the region. Okay, so what we're going to do is we're going to create a box. So we're going to draw a line down here like that, a line down here, and a line across here. Okay, so we're going to find a box, and then we're also going to work out the blue area, actually the unshaded area, should I say, which I'm just going to label S. And then we can subtract S from the box, and that will give us R. Okay, so in order to do that, then we first need to work out the dimensions of the box. So we know that there's 4 along the top here. And the height of the box is whatever the y coordinate is of P. So what we need to do is we need to find the y coordinate of P. So at P, we know x equals 4. And we'll substitute into the equation for y, which is 4 cubed, and then it's 10 x to the 3 over 2 plus k times by x. Okay, so that is 4 cubed, which is 64, plus 10 times by 4 to the 3 over 2 is 8. And then we're going to minus 78 times by 4. Okay, wow, we get minus 168. Okay, so that means the green box is equal to 4 times by 168 in area, which gives us 672. So that's going to be helpful. Now we need to work out the area of S. And we're going to do that by integration, because it's going to be the area between the x-axis and the curve, and that's going to be with the lower limit of x is 0 and the upper limit of x is 4. Okay, so we're going to be integrating the curve, which is x cubed plus 10 x to the 3 over 2 minus 78 x dx between 4 and 0. Like so. Okay, great. So when we integrate that, we'll end up with, so we up the power and then divide by the new power. We up the power by adding 1 to it, and then we divide by that new power, and then here we up the power and we divide by the new power, and that's between 4 and 0. Okay, so let's just tidy that up a little bit more, because this will give us 4 when we do 10 divided by 5 over 2. And this will give us minus 39 between 4 and 0. Okay, and now it's just going to use the calculator to do this. Okay, so I've subbed in 4, which gives us minus 432, and there's no point subbing in 0 because, well, that will give us just 0. So that means that the area of S is actually the positive 432, because area can't be negative, and the reason why it is negative is because we were integrating below the axis, so it's always going to give us a negative value, but because all of it is below the axis, we know that all of it is the area, so we can take the 432 as the area. So R now is just the green box minus S. So we can just say that R is equal to the green box, which we said was 672, minus 432, which is equal to 240. Perfect. Okay, so partial fractions now, and we're going to do, we're going to multiply through by this denominator here. So that's going to cancel out everything on the left-hand side as denominator. And over here we'll get A, and the x minus 2 will cancel with the x minus 2, but we still have to multiply through by 2x plus 1 squared. Here we're going to multiply through by x minus 2, and we're going to multiply through by 2x plus 1 squared, but one of them will cancel, so there'll just be 1 left over to times through by. And then the last time we're going to multiply through, and we're going to cancel out both of the 2x plus 1 squared, so we'll just be left with x minus 2. Okay, and then we say let x equal 2, because I know that's going to be a value which is going to cancel some of these terms. And the left hand side, when x is 2, is 3 times 2 plus 4 is 10. And that's going to equal, when I sub in here x is 2, we're going to get 5 squared times a. So that means a is equal to 10 over 25, which is the same as 2 over 5. And of course, subbing in x equals 2 into this term here is going to make it 0, and this term here is going to make it 0. Right, so we have our a value. Next number to sub in is the value of x, which is going to cancel this bracket, and that will be minus a half. So subbing in minus a half to the left hand side over here is going to give us 5 over 2. And then it's going to cancel this one, it's going to cancel this one, and it's going to give us over here, so subbing in minus a half is going to give us c times by minus 5 over 2. And that means that c is going to equal minus 1. Okay, great. And then the final one to sub in is just x equals 0, because there's no other brackets that can cancel. But if we just sub in x equals 0, we'll get 4 on the left hand side. This will give us just an a, because again that's 0, so it's just 1. The squared is 1, and then times by a is a. This will give us a minus 2 times by a 1, so it's just minus 2b. And this will just give us minus 2c. Now, we know what a is. It's 2/5, and we know that c is minus 1, so that gives us plus 2. Right, so from here we should be able to solve for b by doing 4 minus 2 and minus 2/5, and then dividing by minus 2. So we get minus 4/5. Perfect. Okay, so part B is just asking us to actually integrate this now. So we are going to be integrating then between 12 and 7 the partial fractions as opposed to the big overall fraction. So a is 2/5, so it'll be 2/5 over x minus 2, and then plus b is minus 4/5, so actually it'll be minus. So let's write minus there. Minus 4/5 over 2x plus 1, and then c will be minus 1, but because the power is 2 on the bottom, I'm actually going to write it as just a bracket to the power of minus 2, like that. Okay, so what are these things going to integrate to? Well, this is a fraction, and on the bottom the derivative is 1, so if the numerator was 1, that would integrate directly to ln of just x minus 2, but the numerator isn't 1, in fact it is 2/5 of 1, so it's 2/5 of ln x minus 2. Okay, now for this one, again, the denominator is 2x plus 1, and if we were to differentiate that, we would get 2. So if the numerator was 2, then that would integrate directly to ln of 2x plus 1, but it's not 2. In fact, it's 4/5, which is actually 2/5 of 2. So that's going to give us 2/5 of ln 2x plus 1. Another way of thinking about it is if you've got 4/5 on the top and 2x here plus 1, you could rewrite that as 2/5 of, there must be a 2 there, and then 2x plus 1. You see how these two are the same, because 2/5 times 2 is 4/5. And now this thing here integrates directly to ln of 2x plus 1, so you just need the 2/5 outside. Okay, great. So those two are integrated. Now this one, we can up the power, which gives us 2x plus 1 to the minus 1. We're going to divide by the new power, which is actually going to change the sign to a positive because we're dividing by -1. And we have to divide by the derivative of the bracket, which is 2. So we're dividing by 2, so it's a half. Okay, now if you want more in-depth explanations of how to integrate every type of function, then do check out my 3-hour session that I did on integration over Easter. I highly recommend that. Okay, so now what we can do is we can collect together the lns if we wanted to. So we can say 2/5 of ln, and we have x minus 2, and then over 2x plus 1. And that's because we're subtracting the lns, and because the coefficients are the same, we can just take out a factor of 2/5, and then we can subtract the lns like that. And then plus a half 2x plus 1 to the minus 1. Okay, so now we need to get into substituting. Okay, so the first thing we're going to sub in is 12, obviously, which is going to give us 2/5 of ln, and inside that bracket is going to be 10 on top and 25 on the bottom. So 10 over 25, which is the same as 2/5, of course. So we can just simplify that down to 2/5. Okay. And then when we sub in 12 here, we're going to end up with 25, but it's to the power of -1, so that's a 25th, plus times by a half, so that's a 50th. Okay, and then we need to subtract when we sub in 7. When we sub in 7, we're going to end up with a ln of 7 minus 2 is 5, and on the bottom we'll get 15. So 5 over 15 is a third. and then we're going to add on 7 times 2 plus 1 is a 15th, because the power minus 1 is going to make it a 15th, and then times it by a half is a 30th, like so. Okay, then to finish off, we will subtract the lns, and again, because we've got 2/5 of both lns, we can just write 2/5 of ln, and we can then, when we subtract the lns, we divide the inputs. So 2/5 divided by a third is 6/5. And then finally, a 50th minus a 30th is minus 1 over 75. And that's it. That's a wrap. I really hope you found that helpful. And if you did, I would recommend signing up to my live revision session for paper 1. And that is happening on Sunday the 24th of May. And what we're going to be doing is I've compiled 2 more papers just like these, full of loads of tricky questions on the high value topics, and I'm going to be walking through those papers live in my session. It was a 3-hour session, and beforehand you'll get to vote for which questions you'd like to see me do live, and then after the session you'll get a video recording, you'll get written solutions to both papers, and you'll get video solutions to all the questions. Now, I would recommend, if you are interested, signing up as soon as possible, because last year these sessions, in fact all 3 of my sessions, sold out. So I'm really proud of the sessions. I've had fantastic feedback, which I will put on the screen now, both like statistically, people giving me 5 stars, but also the nice comments and reviews that people have left, which again I'll put on the screen now. So I really hope you found this useful, and be thorough with your revision. Good luck in your exams, and let me know how you get on, and hopefully I'll see you on the 24th of May, and if not, keep an eye on the channel, because I'm going to be releasing more content throughout the exam session. Bye for now.